this is part 2 of the exponents properties foldable. We've already talked about basic exponents. We've already talked about negative exponents. And now we're going to do products with like bases and power to a power. So for products of like bases, it is a multiplication problem, which means it's going to look like that with a multiplication symbol, or it could also have parentheses. Either way, it is a multiplication problem because a product is the answer to a multiplication problem. And we're always looking at ones with like bases to be able to use this rule. So when you do this problem, you're going to keep the base and add the exponents. So add the exponents. I want you to highlight that so it stands out, and keep the base. The base is going to stay the same. So let's do this example. We have a multiplication problem. You can tell right there. And so you're going to add the exponents. And to show that, I'm going to do what we are going to call all year is the little problem that's going to help you get these right, where we're going to write the base because it stays the same, and then we are adding the exponents. And that is how we would get 5 to the 11th power. And because we're keeping everything in exponential form, we don't have to do the multiplication. Look at this one. This one doesn't have a multiplication symbol, but because there are two things that are right next to each other, it is going to be a multiplication problem. So we're going to keep the base and add the exponents. And when you do -3 plus -6, you can change this into 1 minus and simplify that going into the problem to x to the -3rd minus 6 as your little problem. And then if you make a t-chart, you would have -3 and 6. They're on the same side. So you add them and keep the negative symbol, and you get x to the -9th power. Now you already learned that you cannot have a negative answer as a problem with exponents. So we have to do the reciprocal. So we're going to put a 1 under this because for a reciprocal we're looking at a fraction. And we're going to have to move x to the -9th downstairs because they have a negative attitude. And you would have 1 over x to the 9th power. This one is also multiplication. Even though it doesn't have the multiplication symbol, it has the parentheses telling you that it is multiplication. We also have numbers involved. So we're going to multiply those numbers regularly as if they were just 2 times 3. And of course that equals 6. And then the exponents only are with the m. They're not attached to the 2 or the 3. So we're going to multiply 2 times 3 because it's a regular multiplication problem. And then we're going to add the exponents with the m. 6m to the 4 plus 2 would be your little math problem. And then you have 6m to the 6th power. The next one we're going to talk about is power to a power. That's where you have something where it's a number raised to a power and then parentheses raised to another power. And this is also where you will have one base to deal with. So we are going to keep the base and we're going to multiply the exponents. So we have x raised to the a times b. So let's write this, that we want to keep the base and multiply the exponents. Here's our first example. We have 5 to the 3rd power raised to the 6th power, so it is a power to a power. We're going to keep the base and multiply the 3 and the 6 to get, and here's our little math problem that I want you to write, and you have 5 to the 18th power. And the reason we're multiplying is because if you have 5 to the 3rd power, and you do that 6 times, let's see, 1, 2, 3, 4, 5, one more time. The 6th power, if you have 3 5s here, 3 here, 3, 3, 3, 3, that's going to give you 18 5s. So you can just do the multiplication problem to get there quicker. Here's the next one. Let me erase what we have in there. Go ahead and copy that problem down. You can see that it is power to a power because it is negative 4d to the negative third power raised to the second power. So anytime you say raised, you're doing a power to the power. Now that 2 has to be applied to everything inside the parentheses. So because 4 doesn't have an exponent there, it doesn't mean that there's not one there. So this is actually 4 to the first power, d to the negative third power. That is all raised to the second power. So we're going to multiply this 2 with that 1 and with the negative 3. So we end up with 4 to the second power because we are multiplying this 2 because that has to be applied to it because of the parentheses. And then d to the negative 3 times 2. Then you're going to do the multiplication problem. And you see, I've already done the work for you. You have 4 to the second power comes right over. And negative 3 times 2 is negative 6. Well, we can't stop there because we have a negative exponent. So we would put a 1. 4 to the second doesn't have a negative attitude, so they don't have to go anywhere. But d to the negative 6 does, so they have to go downstairs. And that's how you end up with 4 to the second over d to the 6th. And now you're ready to do your homework.